Aloha, Richard Halverson here. This is ITS128, and today's October 15th. Let me share my screen. And the syllabus, October 15th, would put us right about, inside here. We're doing functions. I think I promised I'd finish up these here first. So let's go see where I ended up in chapter 5. And I'm going to try to do these problems by not looking at them too closely, and then try to be careless enough to make some mistakes. So there's some bugs as I'm going along. The reason is so you can see what it looks like, how it responds to the bug. You can recognize by the response that, oh, that's a bug, and you can kind of get an idea what the bug is. And then how I approach solving. Okay, so it looks like we've done 1521 is the last one we did. 5.21, except we didn't do 520. Let's go back and do that. Start there, 520, and then we can go right to 522. So 520. All right, so this is an interesting problem because it's kind of similar. It's almost like it's kind of what goes on inside a program that's doing machine learning. Okay, you're looking for coefficients of an equation that fit. So you adjust the coefficients until the equation, when you calculate the results based on the variables of the equation, then it matches up with something else, and then you've got a good equation to match what the behavior. Okay, so in machine learning, you try to figure out like the mathematical equations for some particular behavior by looking at that particular behavior, hundreds and thousands of times. So anyway, so in this problem, we're trying to find the solution to a set of equations, and basically what it is it's like you have these two equations here, like you have this equation and you have this equation. And you want to find a value for x and y where these are true. You want to find the value for x and y where these equations are true. And so a brute force method would be, first of all, we have to make the assumption that the variables are integers. And then once we do that, we can try all combinations of integers in a particular range, just all combinations, and we try all the combinations, and we find out if there's a combination that works. So so this is okay. So it's this equation. So let's say it's these two equations. This is how we're going to input these two equations. Okay, it's always going to be x and y. It's a linear equation. There's no squares or cubes or anything. And you're inputting the coefficients. See, so you're inputting the 8, and then you're inputting the 7, and then you're inputting the 38, and then you're inputting the 3, and then you're inputting the -5, and then you're inputting the -1. See, so that's here we're inputting the coefficients. The coefficients are the numbers in front of the letters. The letters are the variables. And so we find that if you plug x in for x and you plug y in for, you plug 3 in for x and you plug 2 in for y, that this will be true and this will be true. Is there such thing as a calculator on this? There's a calculator. So I don't know if it's so necessary for me to go through this, but I think I will anyway. So we have x is 3 and y is 2. So we have we have 8 times x is 8 times 3 is 24, plus 7 times 2 is 14. So it's 8 times 3 is that's 24 plus 7 times 2 is 14, and that equals, lo and behold, 38. And x is 2. Excuse me, I'm going to sneeze again. X is 3. I told my family, back when my daughter was very young, I said, no, we can't get a cat because I'm allergic to cats. And so, when my daughter's about 8 years old, they go out, they come home and they have a cat. Now my daughter's long gone. We still have a cat. And I sneeze every day, hundreds of times. But anyway, it kind of cleans up my nasal passages. Okay, so I was going to do this one. 3 times 3 is 9. So it's 9. Let me clear this. 9, and then we're gonna what's minus 5 times 2? That's minus 10. So we're subtracting 10. So let's subtract 10. And does that equal minus 1? Lo and behold, it does. Okay, so you see, that's what we're doing. Well, what we're gonna do is we're gonna first decide that the range of x and y is like minus 10 to plus 10. Okay, and there's some way we can look at that and see that because of what these numbers are. But that's a good, we can make the range bigger if we want to. But so then we're just gonna try all combinations, starting with x equals minus 10 and y equals minus 10, and then do x equals minus 10 and y equals minus 9. And then x equals minus 10 and y equals minus 8, all the way up through where x is equal to 10, or x is equal to minus 10, and y goes from minus 10 all the way to 10. There's 20 of them. And then we do x equals minus 9, and then we do y goes from minus 10 to plus 10. That's another 20. So it ends up being 20 times 20, yeah, because there's 20 here, there's 20 here. So all combinations would be 20 times 20, which is 400. So it's going to test these equations on the value on all combinations of x and y, and once we get something that's true, once we find an x and a y that matches both of them, then we know that we have the solution. Now it's possible that we find x's and y's along the way that'll match one of them or match the other one, but match one but not the other. Okay. And I don't know, we could figure out an example of a value of x and a value of x and a value of y, where the solution is 38, but it's not 3 and 2. But we want to find, if there's a bunch of solutions for this and a bunch of solutions for this, and we want to find the solution in each of them, the same solution that works for each of them. All right, so let's try to write this program. So here we're reading in all of the coefficients and results, and then we're gonna do a loop here. And so let's do we're gonna loop through all the possibilities of x, and that'd be from minus, well, I'm just gonna do this. I'm just gonna copy this. I'm gonna be really lazy and just start with this. And I'm gonna put that here. And it's gonna be 4x in a range, in this range, okay. Now it turns out that that in Python, when you give a range, oh, we got to put the word range here. When you define a range like this, we're actually going from -10 up to 9 inclusive. And that's just how it's, if you think about it, there's a very good logic to doing it the way Python does it. But nonetheless, we want to go from -10 all the way up to 10 itself. So we got to make this 11. And then we're going to do the same thing for y. For y in the range of -10, comma 10 of 11. Okay, so check to see if x and y satisfy both equations. Okay, so how do we do that? We're going to say let's see if it matches x first. So let's see. If I'm just like spitballing here. I'm just gonna. Oh, this isn't. I gotta make sure these tabs properly. Okay. If put that down there, I don't. Oh, that's nice. Let's see. There's two equations. So the solution to the equation is, I'm just going to say S1, solution 1 is equal to A times X plus B times Y. See, I'm just doing this right here. And I'm not going to put spaces here. I'm just going to put spaces there. So A times X plus B times Y equals C, and C has got to be 3. So S1 equals this, and okay, so we've calculated the solution to this equation. We've evaluated this expression and stuck the value in there. And then let's do the same thing for the other one. That's going to be equation 2. The solution for equation 2 is equal to D times X, times X plus what's this here? E times Y. Okay, so this. Okay, so now if this is equal to C, if this is equal to C, and if this is equal to F, then we've got our solution. So if S1 equals C and, oh, it's the word and, wrong language, and S2 is equal to F, if that's true, see, I don't need to put parentheses in this language, do I? If that's true, then we have a solution. So how do I indicate we have a solution? I'm going to say solution equals false. Start out with, just got to be careful. We're going to start out with saying solution equals false. So that if this is true, then I'm going to say solution equals true. Okay, and I want to exit out of here. How do I do that? Break. We learned how to do that, didn't we? Is it continue? It must be the word break. Too many. Okay, so break, and let's just break out of here, and we should still have the values for X. I better save them. I better save them. I'll say X solution equals X, and Y solution, whatever, could have thought of a better variable than that. I'm going to say, okay, it's just like that. And these won't mean anything unless this is true. All right, so that should work. And I should be able to exit. So I'm going to exit. I think the word is break. Let's see, how do you exit? Break out of loop in Python. Break. Yes. Okay. So break. In the meanwhile, otherwise we'll just continue. Yeah. So we'll just continue. So this, otherwise, this loop will continue, and this loop will continue. And so that at the very, so when we break out of the here, okay. Okay, here we're going to break out of this for loop. And then once we break out of this for loop, we should say if solution break. Okay, because we don't need to go on to the next X. See, this loops through a bunch of Y's. And once all the Y's are looped through, then we go back and grab the next X, and then we loop through the Y's again. Grab the next X, loop through the Y's again. But if we come down here and we find a solution, then we're done. We're done looping. So this will break us out of the for loop, and this should break us out of this for loop. And then we're done, and we're out here. And we print, we can print, if solution is true, if solution is true, then print X solution, comma, Y solution. Is that what we do? That's how we do it. Print X equals that. And Y equals that. Otherwise, else print no solution. Okay, so now what I'm going to do is I think this might be all correct and everything. So I'm going to put in some print statements so we can see what's going on along the way. So I'm going to right here, I'm going to say print X equals X and Y equals Y. I'm going to do this. X equals X, Y equals Y. S1 equals S1 and S2 equals S2. Okay, so right here, I'm just going to print out what X is. I'm going to print out what Y is. I'm going to print out what S1 was calculated to be and what S2 was calculated to be. And then we're going to be looking at whether S1 is equal to C and S2 is equal to F. So I want to, in fact, it should stop as soon as this point is reached. Okay, let's just run this and see what happens. I guess I got to put something like this in there, don't I? Copy. Paste, that's the input. And let's run and see what happens. Unmatched parentheses. All right, so we start out, as I said, x is minus 10, y is minus 10, and this calculates out to that, and then minus 9, 8, 7, 6, 7, so 0, or, oh, minus 1, all the way down to minus 10. And then we switch to, no, I'm sorry, minus 10 all the way to 0, all the way up to 10, and then we're done, and we try x minus x is equal to minus 9. So you see on the other side, so on the left side here, x goes all the way to trying all the combinations. Oh, let's see how close we are. We're looking for x, let's find a solution where x is equal to, where, let's find a solution where the first one is true. So it's the first one is equal to 38. So let's find one here where S1 is equal to 38. That's minus 38. Is there one? It's minus 30. Well, the last one should be 30. Yeah, S1 is minus 38 and S2 is minus 2 or plus 38. So I don't see any other. There's no minus ones over here. Well, anyway, so these print statements were put in here just so you can see, the iteration. And we see that when we get to x equals 3, y equals 2, then S1 lo and behold equals 38, S2 lo and behold equals minus 1. And at that point, we stop looping. See, where this is the output. This is the ending output. So we in our program, this is the inner loop, and this is the outer loop. See, and then when we break out of here, then we will break out of here, and then we'll print out the solution. So the solution. So to get the points, you're gonna have to take this out of here. And you can see if that's correct. I think that's correct. All right, so that was 5.21. Yeah, I can leave. Okay, Oh, we've done this one already, haven't we? 5.22. All right. Output values in a list below a user-defined amount. Okay, so write a program that first gets a list of integers from input. Okay, so we've got a list of integers. And so there's different ways of handling like these there's different ways that programs can ask for input, and this is one way where first of all you say how many numbers are going to follow, okay, and then those numbers follow, and then the last number is going to be a threshold. And so what you're supposed to do is you're supposed to output all of the numbers that are less than or equal to the threshold. Okay, so first of all we say we're going to be giving you 5 numbers, okay, that follow. And so you give them the 5 numbers. And by the way, when you do it this way, when you know how many is coming, then you can use the for loop, okay? Instead of having something that indicates that that's the last value. Okay, so anyway, so these 5 are input, and then the last value is the threshold, and we're going to have to presumably store these numbers in a list, and we're going to have to go back through them again. And for everyone that's less than this number, we're going to print it out. Otherwise, we won't print it out. All the numbers less than or equal to the threshold will be output. Okay, so, oh, really? We're going to print this comma too. Oh, well, that looks nice. Okay, so so first of all, let's ask how many numbers. Nums. How's that? Nums equals the integer of input, the number of numbers. So first we're going to get the number of numbers, and then we're going to loop for n equals, no, that's wrong language. For n in range of nums, because, right. So read in 5. So we're going to read in 0, 1, 2, 3, 4 if nums is 5. So we're going to read those in, and we're going to stick them into a list. Better make a list here. Let's make a list. I'm going to call it the num list. Num list is equal to, I need to find a list like that. I think that's a list. And then we're going to go, just going to store them into a list. Num list append. We got to read it. We got to read it in. Int input. Okay, so we can do that. So it'll ask the user for an input, and then it'll integerize it, and then it'll append it to num list. Okay, so we can do it that way. All right, that's it. So that'll read in 5, or however many there are, and then we got to read in the threshold equals int of input. Okay, so that's our threshold, and so now we just need to loop through. Boy, this is such a simple program. Yeah, that's what I have. So we just do it again. For n in range of nums. I wonder if you can do it. Right. I'm going to see if this works. I'm quite positive this will work. So I want to do if num list of n is less than or equal to the threshold, then print num list of n and equals a comma. I'm supposed to put a comma after it. Okay, I'm pretty sure this will work. But what I'm curious about if it works is, okay, so I'm pretty sure this will work. So you can press submit and see if that works. But I'm curious if we can do it this way. And see, we aren't using the n. In this for loop, we aren't really using the n. We're just doing it 5 times, and we're using the append. Can we do this? Can we say that, well, let's read it in first. Let's just do it this way. Can we do it this way where instead of using the word append, can we say this? Input of n equals that. So we read an input, and then we integerize it, and then we store it into this n. And the first time it's going to be 0, and next time 1, 2, 3, 4. I'm curious if this will work. I'm going to try it. I got to have some input. Copy. Paste it here. And I'm going to run the program. Nope, doesn't like that. Got to use append. Got to use append. All right, so instead of doing this, do what I had before, and I think that'll work. Okay, so the reason it says, this is because it says list assignment index out of range. When this is defined, it's defined up here. There is no 0th element. Here we're trying to store into the 0th element. It's a, lists are mutable, so there can be one there already. Well, anyway, so all right, so I think you have enough to do this one. Okay, what's this one? Adjust values in a list by normalizing. Okay, when analyzing data sets, such as data for human heights or for human weights, a common step is to adjust the data. This adjustment can be done by normalizing the values between 0 and 1 or throwing away outliers. For this program, adjust the values by dividing all the values by the largest value. The input begins with an integer indicating the number of floating point values that follow. Good, then you can use a for loop. What kind of advantage is that? I don't know. There isn't one. You don't need a sentinel. You can take in anything, any number. So after we read them all in, then we're going to figure out what the largest one is, or as we read it in, we can keep track of what the largest one is. And then we're going to go back and we're going to divide all the numbers by that largest one. And the largest one is going to have the value of 1. And all the rest of them are going to be below 1. And that normalizes the numbers. So the 5 indicates that there are 5 floating point numbers to follow. And then the 5 are read in. And then when reading them in, we can keep track as we read in, keep track of the largest one. And the first one we read in, we can just set that to be the largest one. And then after that, as we read in, we can, if the next one we read in is larger, then we could just, reset. We have a variable called largest, which will keep track of that. And at the end, we divide it, all of them by that, and we output them. So first I'm going to read how many nums equals int. It's going to be an integer. And then I'm going to read them in for n in range of nums. In that range, read and stored in something. They're stored in something. Something is an array. No, let's be serious. I'll just go numbers. And so let's read them in. So numbers, append, I'm going to do a num equals int input. And then, so numbers is a number, it's a floating point number, and I'm going to append it, numbers, append num. That's going to append num into, onto the end of numbers. And oh, I want to keep track of the largest one. Okay, so I'm going to say, how do I initialize this now? I'm just going to say largest equals 0. Then I'm going to say if num equals 0, then largest equals num. Otherwise, if num is greater than largest, means it exists, then largest equals num. So I don't know what kind of numbers these are. Maybe the largest number is going to be 0. So, or maybe it's going to be, maybe the largest number is going to be less than 0. So if I just set largest equal to 0 and then start reading in numbers and expect to be able to keep track of the largest number, I can't do it this way because I've already set my variable to a number that's bigger than any number that I'm going to read in. So just in case, I check to see if this is the, this is wrong, this should be n. If this is the first number I'm reading in other words, if n equals 0, that means it's the first time through, then just take whatever number you read in and store it into largest, okay? Otherwise, if n is not equal to 0, then that means that we're farther into the for loop. We're reading number 2 or number 3 or number 4. So that means that there is a number there, there's a valid number in this largest variable. So we test to see if the new number that we read in is larger than the one we have stored, and if it is, we want to store that number into the variable a new largest number. Either way, we're going to append it onto numbers. And so in fact, if it may be more comfortable for you if you see it up here. First, let's get that number inside. Let's get that read in number inside this list right away, and then check to see if we're going to reset largest. All right, so this will this is a perfectly fine loop to read everything in and to keep track of the largest number. And then all we got to do is when we print out, we're going to normalize, and normalize means just divide it by the largest number. And so I can just do for n in same thing, nums, print. Am I supposed to do some sort of, oh, they want me to do it this way. Copy. Your value, what's your value? Well, your value equals numbers of n divided by largest. So numbers contains all the numbers that we read in, 5, 30, and then it so I'm gonna put some right statements in here. Print append, I'm appending num. And here I'm saying assign print assign largest equals comma largest, because I just did it. And I'll just say no. And here I'm going to say also largest equals, I'm going to say reassign, so I know that I'm reassigned something. And then here I'm going to print, yeah, this will just print it out. Oh, I want to say print largest equals largest. Okay, just print that out. Okay, let's see what this looks like. So I've added some print statements in there to make it copy, paste. Int, what? Wait, no. It's not an integer. I'm not reading in an integer. I'm reading in a float. This is an integer, but this is a float. Let's see. Okay, so I read in 30 and I assigned the largest value. I assigned 30, I assigned the largest value equals 30. Then I read in a 50 and 50 is greater than 30. So I reassigned largest equal to 50. Then I read in 10, didn't do anything with largest. I read in 100, new largest. Then I read in 65. And then I was done with the loop and I printed out the largest number is 100. And then so then I went through and I do 30 divided by 100, 50 divided by 110, and so on. So it's like that. So you can go in and take out the print statements and so on, get that to work. All right, so let's start with, wait a second, this is where we are? We're on functions now. Yes, okay. All right, let's start talking about functions. We've already been using functions. We've been using methods that are functions that are attached to an object. And we've also used functions with range. Range is a function. Range is a function which returns a list of the values in the range that you request. So, but in general, we use functions to reduce redundancy in programming. And so, for example, let's say you have in your main program, let's say you're computing, you're converting from Fahrenheit to centigrade, and you're doing it for 3 different numbers. So you have the function here, and that's how you read it in Fahrenheit. You subtract 32 from it, multiply it by 5/9, and you get the centigrade. And you do it 3 times. Well, it's possible. It can happen where you make a mistake. And so here we made a mistake. We put a plus sign instead of a minus sign. Well, that's because there's this redundancy here, and they should all be the same. So let's write it. Let's take advantage of the fact that they're all the same and create a function. And so here we're creating a function and we're naming it F2C. That's the name of the function. It's got a parameter here, and that happens to be F for Fahrenheit. And then here we have the function, or we define the function as taking the parameter F, subtracting 32 from it, multiplying by 5/9, computing C, and then we return C. So in the main program, instead of having something like this, this, and this, we say that C1 is equal to, and then the function, and we pass F1 as the argument to that function. See, so it's simpler, so that's the idea. Consider the animation above. In the original program, the Fahrenheit to Celsius calculation appeared how many times? 3 times. So yeah, this makes sure that you understand what's going on up here. It's pretty simple. So function definition consists of the new function's name and a block of statements. It's got the word def up there, and then the function call invokes by the function's name. It invokes the function. So let's say we have a function here that computes the square inches of pizza. You have its diameter, you have the pizza's diameter, and you're going to compute the number of square inches of the pizza. And so the formula for that is pi r squared. Yeah, pi r squared. So we have a value for pi, and r is the radius, and the radius is half the diameter, as you know. So it's if this is the pizza, and this is the center of the pizza, this is the diameter from here to here. That's the diameter, and r, the radius, is just from here to here. So it's half the diameter. So and you square the radius, and you multiply it by pi. So pi r squared, and r is equal to the diameter divided by 2. That's all. This is the diameter, and this is the radius. That's all. But you don't have to know that. All you have to know is, given this equation, you want to be able to write it just like this, where squared is this times this. So this is the r squared times pi, and that's this value right here. So this is a function to calculate pizza, but the trouble with this function is that the pizza diameter is hard coded at 12 inches. So anyway, what is the difference? What's the difference between these 2 things? How many calls? Well, here's one. Here's another one. 2. Oh, 2. Yeah. All right. Anyway, make sure you understand that. What's this now? This steps you through the execution of this, where it comes down to the first statement that executes is this, and then the next statement that executes is this, which prints this, whatever this is. So this has to execute, and that's this. So this executes, and it prints out. It defines this variable as this value string, and then it just returns it. So what's going to be, what is returned here is going to be this. And these are line feeds, carriage returns. So this is what gets printed. And then after that, it prints this out. It's kind of done. So let's just, oh, that's how it prints. So 3 lines. This is the first line. This is the second line. This is the third line. Looks like that. And then that's it. Did it turn out okay? I don't know. Okay, so anyway, that's it. Okay, so here's a challenge. So this method, this function returns 5 characters. Call this twice in a print statement to return and print 10 characters. What are we supposed to do? We're supposed to call get pattern twice, so it prints that. I think you can do this one yourself. Return statements. Okay, so this is how you. Okay, so when a function is called, this is the function. This is a parameter. This is calling the function. This is an argument. But when this is called, you notice it's on the right side of an equal sign. So once this is done executing, there's going to be a value there. There's going to be a value, and that value is going to be stored into here. Okay, so how do you make this be a value? I mean, it's this mechanism here. This return statement is going to return whatever this computes to, and that's going to be the value that goes into the place where that was, and that's this. You see, so that's what that is. So that's what the return statement is. Add a return statement to the function that returns the result of adding this plus this. Well, it would simply be num1 plus num2. Lo and behold. Add a return statement to the function that returns the cube of the argument. Return num times num times num. Okay. Parameters and argument. A parameter is a function input specified in the function definition. An argument is the value provided to a function's parameter during a function call. Okay, I've been stressing that. So this is the definition of the function. So this is called a parameter inside. When we're talking about this thing, it's called a parameter. When we're talking about this thing, it's called an argument. That's all. Complete the function definition to have a parameter named numGrade. I guess we just put numGrade right in there. Call a function named that, passing the value this. Okay, well, you just put that there, but inside the parentheses, you put 21. Is the following a valid function definition? Is the following a valid function definition beginning? Type yes or no. No, it's not, because this has to be this is like the left side of an assignment statement. There's something that's put in there. When this is called, there is a value that's put in for right here. And so this has to be what that value is called. So it has to be a variable name. Just like you cannot have, you can't have, pizza radius times 2 equals pizza diameter. You can't have that. I mean, that's accurate, but I mean, it's not smart enough to know, oh, pizza radius times 2 equals pizza diameter. Well, really, I want, just pizza radius on the left-hand side. So I would divide both sides by the 2, or, so anyway. So that's the problem with this one. And so the answer is no. All right. Of course, you can have multiple parameters. You can have no parameters. You can have defaults. And there's different ways that you can pass parameters. You can pass parameters in an order, or you can pass parameters by specifying what the variable name is, what the parameter name is, equals a value. So here's an example of calls with multiple parameters. 3. Okay, so in this one, given a function call this, given a function definition this, it's a function with 3 parameters. That means when you call the function, you have to pass it 3 arguments. Does this pass 3 arguments? No. Does this pass 3 arguments? Yes, it passes a k, it passes whatever I plus j is, and then it passes 99. Here, this only passes 1 parameter, or this only has 1 argument. You add, so anyway, this is the answer. Did I just do this one? I did that one already. Hierarchical function calls. Of course, you can have functions calling functions. No reason why you can't have that. So here we have, here we're calculating, here we're asking what the pizza, whatever it is, the calories is by this calling this function, which is this function, and this function calls this function. This function is this function. So to figure out the calories, it takes the diameter, figures out what the square inches is, and then it multiplies that by some factor, and then that's what it returns. By the way, notice that, speaking of functions and arguments and parameters and so on, well, we're talking about this function in here that's got this argument here. Well, actually, this is a function. This is a method, it's a function, that it comes along with this object. This is an object. It's an object. This is a method that you can operate, that can operate on this object. And oh, guess what? This is a function. And this is the argument to that function. Single argument. So anyway, very interesting. We've seen it all before. Okay, we're supposed to answer these questions. Type the expression for placeholder A to calculate the total calories for a pizza with the diameter of that. So total calories equals, what is it? Pizza diameter times, what is it? 16 point something? 16.7? That's the diameter? No, I got to first calculate the, first I have to calculate the area. Okay, so I have these methods, I have these functions available to me. So I need to, so pizza diameter, total calories is, it's this. Copy this. Oh, what happened? I want this. Oh, I see. All right. Total calories equals, well, let's see. Let's see if this is right. No, it's not. Pizza calories. This is not a very easy thing there. Returns of pizza's total calories. Okay. Given the pizza's diameter. Calc pizza calories. Diameter is passed as an argument. Oh, this is the diameter. Is that right? Yeah, that's right. Okay, anyway, what time is it? Oh, we have, let's do a couple of these. Let's just do a couple of these real quick. Okay, complete the function definition to return the hours given the minutes. This is the minutes, and we're supposed to return the hours. Okay, so we read in the minutes, and then we print get. Oh, so okay, so we got to put a function in here. Return original minutes. Divided by 60. Yeah, okay, good. What's the next one? Define this with parameters of this and this. It returns a total number of inches. Note there are 12 inches in a foot. So I want to calculate total inches. Num inches times, well, let's go feet in inches, and it's supposed to return the total number of inches. Okay, so feet, inches, let's calculate. Oh, okay. So I need a method that looks like that. Functions. Def this, and I'm gonna say return feet times 12 plus inches. That be it? Yeah, all right. Let me just do one of these. Write this x5, print 5, enter. All right, you can do the next one. This is last one. We're supposed to return inputs and we're supposed to multiply base area times height times 1/3. Is that how you figure out what the, oh, okay. Calculate a pyramid. So it's something like this. Def that colon return base area. What's the base area? Base length, base width, base height. Base area must be width, base width times base. Okay, so I'm going to say a base area must be okay. Now there's two. Base area equals, I would say it's equal to the length times the height, no, times the width. I'd say that's the base area. And the volume equals base area times the height times 1/3, 1/3. So this is this, this is this, this is this, and this is this, and this I return volume. Well, I'm gonna see what happens if I do this. See an error. One-third of 28.35 is probably 9.45. So anyway, I think you have enough to do this one too. All right. So I have finished section 6.1. And next week I'll continue. Any questions?
Hey, I have a question.
Mm-hmm.
This is Tan.
Mm-hmm.
Do you can help us on the weekend too, or just weekdays?
Yeah, I'm here every time. There is no weekend in my house. Anytime. Just yep.
Do you? If I just email you then, because I think if we can I'll get another friend of mine, and then we have questions at the same time.
Yep, very good, excellent. That's a good thing, and you can text me also if you want to. My phone number is on the front of the. It's on the syllabus. My phone number here is. You got it right.
Yes, I got it.
Okay.
Since you're here,
Yes.
Is it okay if we see you this weekend?
Yes, it is. Yes, it's okay to see me this weekend.
Yeah. Whatever times you have, because Vince and we're gonna see you. We have questions already, but we're doing projects together, and then we have it on Revlit, and it's just easier to show you. And then we type codes in there, and then we have questions, and then we type it out codes.
Very
so
good.
Just give us the time, and we'll see you.
Okay, so I have I'm sorry, I'm slow at looking at the LaLima posts. I gotta get it. That's a new thing I'm doing, the LaLima posting, and I the first time I did it was actually last summer, and I have to get that into my routine. But anyway, the only thing is tomorrow in the morning tomorrow AM is not good. It's a Saturday. Yeah, Saturday in the morning is not good. But all day Sunday is fine. I don't never do anything on Sunday. Saturday in the afternoon is fine. So.
Okay. Yeah. So yes, we will. I will ask Vince, and then we'll text you for tomorrow, Saturday afternoon.
Okay. Very good.
Thank you so much, Professor.
You're welcome.
Yeah, thank you.
See you then.
See you tomorrow. Bye bye.
Yeah. Take care.